Algebra 1, Term 2, Lesson 9, Systems in Action. We'll first look at cell phones and actually several different tasks within a Desmos activity, then a would you rather task, and then finally what is X. So let's start with our Desmos activity. This activity is not that long. It's only got 14 slides. The first part is simply a linear equation. It's not really a system. But the last half of this task is. You may have seen this first part. This came straight out of one of the Desmos activities. But here's just making a prediction and then filling in a value in a table. And then creating a line to go through the data, which will then give them an equation, and then they'll use that equation to calculate when they believe it would hit 100 based on that equation, and then interpreting in a context. So all of that is pretty simple, and it is a system sort of because it's hitting 100, but we're getting into true systems when you get to slide 8. And on 8, you're given a system with 2 different phones, and this time the charge of the battery is decreasing instead of increasing. And so different scenario, but they're going to basically give me equations to represent phone A and phone B. You may want to tell them to use latex here, that is, use the math type button when they type so that they can get a nice looking equation. I don't really give them any specificity on how to type it. They could do a function like a of x, or they could just put y equals. And there's no form given either, so they have options there as well. So encourage diversity, that would be great. And then I do have some teacher moves sample responses for you, so take a look at those. On this one is self-checking. I don't think it checks on the dashboard. It does tell them if it's right or wrong, so it's mostly for the students, but it will say try again if they don't get it, so that's kind of nice. But again, they're giving me the solution to this system, and it's basically interpreting that solution in a context with these questions. And then now we're going to be given a totally different scenario. This is the cost for a phone plan at a phone company. So there's 3 plans, M, Q, and Z. So which plan do they choose? At this point, there's no wrong answers. You know, they may have their reasons for choosing one over another, but they should go ahead and type their ideas here. Encourage discussion, even debate would be nice. And then on this one, they're going to graph the 3 plans here, and your function here is in terms of the number of months. So it's irrelevant. The data is irrelevant, and I'm sure that's going to be a focus for some students, but that's not what we're comparing here. We're just going by the cost of the plan as a function of the number of months. And then once they've done that, then they're going to evaluate their function that they created for each of the plans, and then tell me which is cheapest based on that equation. And then a month later, what's the cheapest? And then finally, what about 3 years from now? So they'll need to know there's 36 months in 3 years. So they'll plug a 36 into their equations. And then finally, does this information impact your choice? So you could have a conversation there. So let's take a look at the remaining 2 tasks in this lesson. We'll go back to the slides for that. The first one in the slides is a would you rather. Now this one would be ideal to do as a building thinking classroom task, and you could simply give them a slip of paper with this information on it, or they could work in their teams and then maybe go put their final verdict goes up on the board, and maybe they need to come to an agreement as a team. I mean, it's kind of up to you how you want to do it, but I would ask them to tell me which choice and why. And you know, there's actually no right or wrong answer here. It kind of depends on what you believe is going to happen. But one of these jobs will pay $28 an hour with no tips. The other pays $16 an hour, but having a possibility of tips. Now, that's a question. Is that a 100% possibility? Is it a high probability? It does say the average customer tips between 10 and 15% and typically purchases around $40. So if that's consistently true across the board, then maybe that'll help influence the decision. But they do need to come up with multiple representations. And so in their notes, I include a list of 4 things that would be words, graphs, tables, equations, and they need to choose at least 2 of those, because multiple means more than one. So at least 2 of those representations need to be used to determine their answer. So not just words, but give me some kind of math here. Now this cute little picture of these children, they can delete that. This text, they can minimize that, maybe make the text really tiny and put it over to the side. They don't have to really type here where it says that if they've got their work typed or written out in some other way. So if they were to do this on the whiteboards, for example, they could just take a picture and insert that with their conclusions. Or you know what would be even better is to have a video. So if they were to make a video as a team and talk about things they looked at and what they thought, and that would be extremely good. That would be a great artifact too in a portfolio, because this is kind of a personal decision too. Like, do you know what your choice is here? That would be good. All right, let's go to the last task. Now the sequence of these tasks is, it really could be flipped. If you want to start with this, it's kind of like a puzzle and then come back to it at the end. But what this is doing is it's kind of building a need for equations. Now the kids, if they already know how to solve systems of equations, they may instantly go there, and that would be good. But some won't. And something you might want to point out if you catch them doing this, if they take something off any of these, it's going to make this go out of balance, like this one on the far right, because all of these are balanced with this one thing here. So they need to keep that in mind. You can't just start taking stuff off. If you take this 1 off, you could take that 18 off, but then these won't balance. So you can make that a 17, but it won't balance. If you take this y off, you could take this y off, and this would be balanced. But guess what? This wouldn't be balanced anymore. So I thought of that, and you may want to talk about that even. Maybe pause the activity, go, can you take anything off? If you do, isn't it going to affect one of the balances? Because you have 3 different ones here. Something to think about. But this task it's not designed for them to do equations, but it does give them a purpose for doing the equations. And in the next assignment, we will do some of those balance problems so that they'll see this again. So this is kind of an introduction to something, and it's a real complicated version of that. But I thought it would be a fun one for them to tackle independently and then with their team, and then present their solution strategies. And I will give you a potential strategy in your notes, but I wouldn't share that with the kids. I would see what they can come up with. Let's see what they can do without any direct or formal instruction. And that concludes Systems in Action. Next time we'll get into some algorithms, we'll get into some equations, and we'll get into some formal methods for solving systems. Y'all have a great day.